Okay, guys, welcome back. So, this is actually the second part or the second chapter I'll be talking about on physics. So, this is actually, in my preference, is the most important subject matter or the subject content of physics, mechanics. So, in the first part of the lessons on physics, I explained to you about the vectors and the relative velocity and a brief introduction to the concepts of physics. So, mechanics is what I consider and what many consider as the most important part, because mechanics is used everywhere. Now, if when you are walking, when you are eating, anywhere, right? Anywhere, it's used widely other than the other concepts, right? Other than the waves, heat, gravitation. Gravitation is also equally important as mechanics, and current, electricity. Mechanics is used everywhere. When you are even talking, you use mechanics, right? So mechanics is actually like the life of a person. So mechanics can't be taken away from the life of somebody or the behavior of some non-living object. So mechanics is important due to several reasons. So all mechanics is also the largest, actually the largest subject content that you will come across on physics. And due to this reason, I have divided my video and my presentation into three parts: mechanics part 1, mechanics part 2, and mechanics part 3. So mechanics part 1 is further divided into three parts. In the first part, I will be explaining you about the Newton's laws of motion. So that will be the content I will be aiming to conclude in this video. The second part will be conservation of linear momentum and collisions and the related concepts. And the final part will be about the types of forces, friction, and the related concepts. Alright, so having given a brief introduction of what I'm going to do on mechanics, in this video, as I mentioned, I'll be explaining you about the Newton's laws of motion. Alright, so to begin with, what are the Newton's laws of motion and why do we use those? Alright, so Newton's laws of motion. So Newton expressed three laws of motion about the linear motion, in fact, linear motion. About the linear motion, and he expressed three laws called the first law, the second law, and the third law. So first law is also called the law of inertia, so because it explains about the inertia of an object, so I'll explain about those. So before explaining about these laws, I will always use a practical example to you so that you are well aware with the concept what I'm going to talk about, and then I'll explain you the law. To begin with, I'll explain you about the Newton's first law first. Alright. So as I mentioned, Newton's first law is also called the law of inertia. So to begin with, as I mentioned, I will use a simple example. Now consider if you have some knot here and you have a string or a rope or something, rubber or something that you can stretch here, you can create a force. Even if it is some metal, it's not a problem. But the only thing is that it should be a tangible object in which you can create a force, you can feel a force. So I'll explain a simple example using this about the Newton's first law here. So you are here, and one of your peers or someone who can participate with you in this work is in this position, right? So there are two people here. So I'll tell you to drag this rope in this direction with some force. Now it can be due to two types of forces. One type is that an increasing force, that of an increasing force. Now say you hold the rope, you increase the force from 0, 1, 2, 3 like that, say up to 20 newtons. And in a similar way, your peer or any other who is participating with you in this work is also increasing in a similar way from 0, 1, 2, 3 up to 20 newtons. So first of all, I will consider the forces to be equal. And the second way of creating that force is a sudden impulse, right? So impulse is a sudden force that is observed within a very small time. So I'll explain about what is meant by impulse when I'm talking about the Newton's second law. So for now, remember that impulse is a sudden force, a force that acts and creates some effect within a very short time. So due to these two reasons, due to these two ways, in fact, you can create some force on this rope. Now when the forces are equal, say you give a force of 20 newtons, the one who is participating with you with this work is also exerting a force of 20 newtons. Although they are equal in magnitude, they are opposite in directions. Now you know that the force is a vector. So if you want to make a force, if you want to change the direction, or if you want to flip it horizontally, you know that you have to enter a minus value here. So the minus value says that although this is equal in magnitude, it's completely opposite in direction. So you know, according to the vector theory I explained you, right? Vector theory explained you can even feel this, that the rope will not move because the net force on this object is 0. So the net force is also called the resultant force. So you know about the resultant when I talked about that in the concept of decomposition of vectors, solving vectors, and the other related concepts of the introduction videos on physics. So the net force or the resultant force or the total force will be F plus minus F, which is 0. So when the net force is 0, you can feel that, and also you can say that the object is stationary. So we conclude that for an object to be stationary, that the net force should be 0. Now this is completely opposite when you increase this force. Now you keep this force, you can increase this force by either adding an angular, a vertical, or a horizontal force. So in this concept I'll only use horizontal force as these two forces. So I'll increase this force, say this is 20 newtons initially, this is 20 newtons. So I'll increase this force either by increasing the same force or by providing another force. I'll increase this force to say 25 newtons. So this F is now 20 newtons, this minus F is minus 20 newtons, so 20 newtons in this direction, and this R is 5 newtons. So the total net force, or the net force of the resultant force, is F minus F, which is 0, we calculated it here, plus R, which makes it a total force of R. So you know that the total force is R. So when the total force is R, the net force is not equal to 0, R is not equal to 0, and the net force is not equal to 0. So the object becomes mobile, or the object moves in some direction, right? So one example that we can experience is using the string, and another example is using a carom ball, right? Like you can say that the carom ball will not move until someone hits on it. You can experience that in the game of soccer, in the game of cricket, in various other games as well, and even in not even games, you can experience these in numerous occasions in day-to-day activities. When you don't exert a force, or when you don't have a resultant force, an object will not move, or when an object will not make any behavioral change. So Newton's first law, as I explained using this example, explains about this occasion, or this behavior of this matter. So Newton's first law says that an object remains at rest, right? Remains at rest unless acted upon by a net force, right? So if there's no net force, as in this case, if the net force is 0, the object is stationary or remains at rest. However, an object in motion remains in motion unless acted upon by a net force. So that's the same instance. If you move in this direction, because you can't say that the object is stationary, the only stationary, it can also move with a constant velocity. However, the movement is not changed until a net force like this R is acted upon it. So the converse of this theorem is that when some force is acted upon some system, equilibrium system, or a system which doesn't have any external forces, that object will change its motion, and either a moving object will accelerate or decelerate, and a stationary object will start to move. So that's it about the Newton's first law. So due to this rest and the reluctance to move, we call this also as the law of inertia. So that's it about the Newton's first law. So here I'll explain about the Newton's second law. So Newton's second law is actually about the acceleration of an object. It's actually due to the change of momentum. Now you can say that according to Newton's law, the change of momentum per second is proportional to the applied force, and the momentum change takes place in the direction of the applied force. So what happens is that the change of momentum per second is proportional to the applied force, means F is proportional to the momentum per second. So momentum is actually, then momentum is equal to mass times the velocity, and that divided by seconds is mass times velocity divided by second. So F is directly proportional to mass times velocity change per second, right? You can also say F is proportional to m delta v over t, or m times delta v over t. So delta v over t, or the change of velocity per second, is actually the acceleration, the rate of change of velocity. So F is proportional to ma. So to remove this proportionality, we equate it with a constant. So F equals then k times ma. I'll use the constant as k. So when F is equal to 1 Newton and when m is equal to 1 kilogram, A should be, and when A equal 1 meters per second square second, then k is equals 1. So we get the popular definition F equals ma in such a derivation. Another way of proving the Newton's second law is using the momentum change, the direct definition of the momentum change. So what we did here was that we actually went in a detour, right? So we call mass time the momentum change in the first line as mass times the change in velocity per second. So another way to express this is the direct derival, right? So direct derival of the force here. So direct derival of the change of momentum per second. So according to that derival, you can say that force is equal to the momentum change per second. So I'll take the momentum to be p. So you know that p equals mv, right? So m is equal to m is the mass and v is the velocity. So when I substitute mv in place of p here, I can say that F is equal to d mv over dt, or we are actually differentiating mv on the basis of t. So that will be, I can take the mass out because mass is a constant. So mass times dv over dt is A. So F equals ma again. So that's it about the Newton's second law. One of the applications of Newton's second law is that, now say if an object is at rest, you give some acceleration to an object, or if you change the acceleration of an object according to Newton's first law, what happens is that you can calculate the force. Also, given some force, that's the most popular example, given some force, what generally happens is that you can calculate the acceleration given the mass of the object. So those are actually simple applications of the day-to-day activities that you may have already experienced. So the final law about the Newton's laws of motion is the Newton's third law. So Newton's third law is something like this. Now say that you have some tennis racket or something like this. Now when this ball travels up to this one, when you are playing tennis, you can experience this. When the ball reaches the racket, you can say that ball exerts some force on this. So if you are holding this, you can see that you can't initially hit this ball in this direction. If you are actually, in reality, you are playing this, you can see that for a very minute time, this racket will move in some angle direction like this, right? So it will move in this direction for some time, and then you will allow the ball to move in this direction, and then you will hit it in the other direction. So when this ball travels in this direction, this ball, we say that the ball exerts some force. So there should be a force because your hand is not turning the racket. You are keeping your hand at rest in relative to the racket as well as in relative to the earth. However, this object makes some force resulting in the acceleration of this object. However, you actually provide a constant force to this racket. So this racket will not move, but it will somewhat rotate to some angle. So that's about the analogy between the linear motion and the rotational motion, which I'll be describing in the mechanics part 2. So don't confuse with that. Just remember that when you have some force, this racket experiences that force. However, initially what happened was that this racket was initially at rest. This ball moved in this direction. So this racket will not bear that force or the pressure exerted by the ball. So this racket will exert the same pressure or the same force on this ball. right? This racket will experience the same force on this ball. So if this red arrow is the force, the magnitude, the length of this is the magnitude, and the arrowhead is the direction of the force exerted by the ball on the racket. By the ball on the racket, the force experienced is in such a direction and with such a magnitude. So the force exerted by the racket on the ball is in such a direction, and actually it's opposite in direction but equal in magnitude. So that's about the Newton's third law. Newton's third law explains that to every action there's an equal and opposite reaction. So if the action is the ball hitting this tennis racket, the reaction is that the tennis racket expels some force, right? Extend some force on the ball. So this action, the force exerted by the ball on the racket, is equal but opposite in direction to the reaction experienced by the ball or the force exerted by the racket on the ball, right? So that's it about the Newton's third law. So as I mentioned, I'll explain about the impulse and the other concepts here. So some key terms of the theories that you will come across when you are solving Newton's laws problems is about the impulse, the inertia, and the terminal velocity. So what is impulse? So at the beginning of Newton's first law, I explained to you what is meant by an impulse. So impulse is a sudden force. So although impulse is a sudden force, how does impulse create such a force? So impulse is actually the change of momentum in a collision, or the product of the force exerted and the time taken for the collision. So now what actually generally happens is that this impulse creates a change of momentum. So we generally express the any change, a change of energy, change of momentum, change of work, anything, as in a delta quantity, within a very minute quantity. So delta mv, so right, that's actually the mass times the change in acceleration. You can also say that delta mv is equal to m delta v, because you don't change the mass of an object, we consider. But there are occasions in which we change the mass of an object also in the case of change of momentum. But for most occasions what we do is we keep the mass constant and we change the velocity. So delta mv is also equal to m times delta v. So what generally happens is that the impulse is due to the change of momentum. So this change of momentum creates a force within a very minute time. So due to this we experience some impulse force, right? Now say some wooden block hit your body, right? So you will experience a sudden force, and that is due to the impulse, a force that is acting within a very small time. Now that wooden block that fell from some height would touch your surface and then would fall back, but it took sometimes milliseconds, microseconds or nanoseconds, but that created a force. So that's the impulse force, and that also created a change of momentum. Now the mass of the object, mass of your mass as well as the mass of the wooden block didn't change, but some velocity was harmed, and due to that velocity some energy was harmed, and that energy transformed into some force and was absorbed into your body. So that's the reason as to why you feel it. Your nervous system feels it. You feel the impulse force due to the change of momentum. And the second key term I had to explain to you is about the inertia. So what is the inertia? So inertia I actually explained in the concept of Newton's first law as well. So inertia is actually the tendency of an object to remain at a constant velocity, or its resistance to be of being accelerated. Now in the case of an object, when an object is either stationary or when an object is at rest, what generally happens is that this object doesn't want to move. It's reluctant. It doesn't like to move. It doesn't tend to move. So that reluctancy or the tendency to remain at rest or remain at a constant velocity or move with a constant velocity is what we call the inertia. So inertia explains the basis for the Newton's first law. So to get rid of inertia, we have to exert some unbalanced force on a system or a system of forces that will make a resultant force. So terminal velocity is actually, although I explained it here, is actually a concept that will be discussed in later videos on Mechanics 2 and Mechanics 3. my videos on mechanics 2 and mechanics 3. So I'll just give a simple introduction. So terminal velocity is the maximum velocity of an object falling from a height or moving from rest through a frictional medium. Thus, at terminal velocity, the total resistance acting upon an object should be equal to the gravitational attraction force. Now, if an object, say you drop a ball from some height, and this ball actually gets drowned in water or in mud, right? What generally happens is that there is a frictional medium. Although you consider that the air to be there is no drag on the air, there is a frictional force, because what is a liquid, and mud or any other liquid is a liquid, there is a frictional force. So that I will explain in the concepts of states of matter and the elasticity and the other concepts. So due to this drag or due to this resistance through this frictional medium, there is a maximum velocity that this object can achieve. So that velocity is called the terminal velocity. Don't confuse with the term of terminal velocity. You need actually only the inertia and the impulse as the key terms here. I explained to you due to one reason. I'll explain as to why I explained that in another video when I am explaining about the further topics of mechanics. Alright, so that's it about the Newton's laws. So hope you gathered some knowledge and some examples about Newton's laws. So in the next videos I'll be explaining you about the types of forces, collisions and the other concepts related to mechanics. And also I will certainly add some videos, some practice videos with some practical examples about Newton's laws. So hope you enjoyed this video and gathered some knowledge, and thanks for watching this video, and see you soon.